So during this project, I learned a number of different aspects that dealt with mechatronics. The main thing I worked on during the course of this project was the sizing of the stepper motor and the servos that we used. The main issue we had with during this part was that our NEMA 17 motors that we had gotten from some people, we quickly found out those only had a torque of 0.49 newton meters, which was not nearly strong enough to move our arm. Doing some math and calculations, we figured out that our arm would need around at least 4 newton meters in order to rotate. So we looked at some of the different options we had, and we found out that a gearbox ratio of 51 to 1 on a NEMA 17 would give us an output torque of 6 newton meters. So we decided to use that one. I also learned the importance of using state machines, especially when you have a bunch of different actuators and servos going on. The main reason state machines were so important is because we were able to have a couple sensors, and those sensors would return different values to the Arduino based on either how hard the FSR value registered to force, or if the gyro recognized that the pitch was not horizontal. So by having different state machines and having the different servos directly react to those state machines, we were able to have our claw and our wrist automatically adjust based on how hard the claw was closing or how the wrist was angled. If it was not horizontal, it would automatically rotate itself.
My name is Nawar Saleh, and I am part of the ME106 Robotic Arm project. A few things that I learned through this project. I learned that we need a good quality 3D printer. In order for our parts to fit well when we were assembling, we had to have a good resultant finish from the 3D printer, which we did not. So we ran into a lot of issues. We had to make washers, spacers, and whatnot. Another thing I learned with this project was also the wiring. We had a lot of trouble soldering the wiring. We used solderless breadboards, although they did cause us a lot of trouble because our components were so small, such as the gyro sensor, and when we tried to solder it, it was very hard to solder. Next time I would get ready to plug in wires, most likely. Another issue that we ran into is with the base. Instead of using wood, maybe we would have used like a cardboard or a plastic, since we didn't have enough time to 3D print it and we waste a lot of material. One of the biggest lessons I learned about this project is next time do not combine 154 and 106 together. It made this project much harder due to requiring four bar linkage mechanism. Next time I'll do a solo project, and instead of...
In this lab I learned how to program the Arduino to interface with motors and servos. A lot of this was done using electronic components like capacitors, drivers, and resistors. A lot of the code that was generated was used using a state machine type of approach. This helped a lot with troubleshooting because we were able to identify which states were working or not working using the serial monitor and entering series of text like I'm in this state. It helped a lot when we were interfacing with the driver and the motor because it allowed for easy access to what was going wrong with the motor, or if there was a connection that was faulty because the stepper wasn't working. One instance we found was that the stepper driver was not interfacing with the motor correctly because it was not given a good enough amount of power from the Arduino because we had too many things running from it. So in order to troubleshoot this, we use a different power source to power some of our servos, which led to less current being drawn from the Arduino. In the end, I learned a lot from this project because it helped us use a lot of motor interfacing and coding and pretty much bring everything all together in one project, which is really helpful because a lot of mechatronic systems are similar to this, where we have a sensor and we have to be able to bring a mechanical system into it and integrate electronics, and a lot of the world's technology today is going towards that, and it's exciting to see how we can make an impact in the world.